Okay, so Slobodan Simonovic is going to join us now. He's the research chair in a very important area for us of the Institute for Catastrophic Loss and Reduction. So,
thanks very much. I'm very happy to be here with you and share a little bit of experience, my personal experience related to the water cooperation team of this year, World Water Day. I am probably the oldest around and been involved with water for a very long time. And when I was asked to talk about this topic and when I saw the choice of the team for this year, World Water Day, I was kind of reflecting on the past and how many projects that I was involved with had a component that was dealing with resolving conflicts and supporting cooperation. The situation around us is pretty dramatic. The population is growing very, very fast. The predictions are by 2050 we will have 2 to 3 billion more people on Earth. That increase in population requires tremendous investment in food production, and the prediction is that this increase of 2 to 3 billion people will increase the food production for about 70% by 2050. And when you mention food, you realize that in most cases water is very, very much involved in that process, as well as used for kind of irrigation. So there is a very close connection between population, increase in the food demand, water use, energy required to produce the food, and all these connections are emphasizing the competition for the relatively limited resources. About 150 countries around the world are sharing basins, so the cooperation or the need for cooperation is really prevalent. If you look at I think the number right now is around 280 shared river basins within these 150 countries. You realize, for example, how many basins we share with the United States, and Russia is one of the countries that shares about 30 basins with surrounding countries, and all these kind of issues that are involved in kind of international cooperation around the water require very, very serious investment in finding the way how we can develop the language and do the best to protect and use the resource in the most efficient way. I decided to actually present you with 2 examples that I was involved with, and Jeff was panicking when I entered the room because I said I changed my slides. So this example is prompted by the decision this morning that the province of Manitoba again called the state of emergency for the southern part of the province because of the tremendous amount of snow that covers the Red River Basin. They are saying, and the revisions from yesterday of the U.S. forecasters, that they're saying that more snow is available than in 1997 when the basin was completely under the water and that area experienced the flood of the century. This is the picture from 1997. This is the kind of situation we are facing here, and I'll try to explain the conflict and cooperation. This is the city of Winnipeg, about 700,000 people. And this is the border with the valley. That's south, that's north. The valley, or the area between the U.S. border, U.S.-Canadian border, and the city, approximately 38,000 people, mostly agricultural land. And in order to protect this large population, very serious infrastructure has been constructed. And this infrastructure includes one of the probably most known pieces of flood control infrastructure known as the Red River Floodway, and this is the structure that diverts the water into the floodway, and that's the river that goes through the city. You almost have 2 parallel rivers flowing during the periods of very high flows. The point is that this border represents also the border between the kind of rural and urban community. That operation of this structure and the way how we decide and when we decide to divert the water into this canal has some impact on the communities, obviously downstream from this point. And immediately that point, even that we are talking about the same kind of use or same issue, same water issue, flood protection, the conflict is kind of appearing as the conflict between the urban environment and the rural communities in the south. So the problems that are being kind of emphasized is how you operate this structure. This is definitely being done to protect this very large population, but on the other side may create some conditions in the southern part of the valley that contribute to flooding. So the communication and cooperation is, tremendously important in determining the exact way how you are going to operate. How are you going to share these potential consequences of the potential flood and proceed in a way that all the citizens or everyone who lives kind of in this basin is treated equitably. Another example is from outside. I was involved with this project through CIDA involvement, looking into the Nile River sharing, and that's a very interesting international example. Nile, as you know, is basically a source of life for many countries in this part of Africa, because it's mostly kind of flowing through the desert and provides the main source of water for drinking, for food production, for industrial development, and so on. The interesting point in this basin is that there are a number of countries. Egypt, I'm kind of starting from the north, moving south, Sudan, Uganda, Ethiopia, Rwanda, Congo, Eritrea, Tanzania, and Kenya, and they're all kind of sharing the same river. That river carries approximately 84 billion cubic meters of water every year, and by contract, Egypt gets 55 billion of that. So the situation is right now that Egypt, which is obviously the most developed in this part of the world, is taking a lion's share of this water and is affecting what is happening in the other countries, upstream. So from the history of the development of Egypt and agriculture in Egypt, the Nile and the area around the Nile was playing a very important role. This is a photograph of some early 1940s, where you can see the early irrigation works in place. And the situation that is right now in place is that the whole region is facing tremendous increase in the population. Egypt is crying for more water. They are talking about increase of this demand from 55 billion cubic meters per year that they are receiving to 7 more, basically 62. Where all other countries that I mentioned are already suffering the major deficiency in the water supply. And that's very easily creating a kind of conflict and tremendous need for cooperation, exchange of information. The commission is established to look at the Nile River to try to come up with agreements. The negotiations were restarted in 2010, and there is no solution in sight. Canada was contributing to our kind of international assistance. At the point when I was involved with the project, approximately $300 to $400 million was invested of our taxpayers' money to actually help the resolution of the problem of the water use, especially in Egypt and related to agriculture. So these are just 2 examples that are illustrating the existence of the conflicts and different potentially types of conflicts that we may need to deal with. What I am involved with at University of Western Ontario and the Institute is use of the systems approach. And the systems approach is basically nothing else than seeing the problems in a little bit different way. Seeing the problems as a kind of set of different components that are kind of working together, they are interconnected, and these interconnections and the way how we select these components are determining the way how the overall system responds. So the conflict and the support for the cooperation can be nicely approached using this approach by simply selecting what are the key players, the available water, let's say the use within the country of Egypt, or use in the other countries, or the urban community of Winnipeg versus the valley communities in the Red River Basin. Then look at the kind of natural forces that are changing this. how much water comes into this, provides the renewal of that resource, how much water is being, used or what is the level of protection for one or another user. And then connecting them all with kind of interactions that are defining the way how they affect each other. And when you do this, we call these diagrams spaghetti and meatball diagrams, where at the end you have a number of loops, and these loops are defining basically the feedback relationships, and these feedback relationships carry a certain type of behavior that we can better understand the complexity and the performance and the behavior of the complex systems. So we can supply some information to that, and then basically run the simulations through this kind of modeling tools, investigating the potential options for cooperation. I'm running here this is just animation of the results thanks to one of my assistants, Roshan, where we are on the bottom slide seeing how is, for example, the allocation of the resource being shared between two different competing users, and on the upper graph, the level of dissatisfaction with this particular allocation kind of evolving over time. And as you can see, like when they reach the kind of allocation, that's, I don't know, 10 units to one and 40 units to another, they kind of reach the level of dissatisfaction which makes them both, equally unhappy, I would say, but at least provides the opportunity to kind of look at the problem, and by changing possibly the conditions, the initial conditions, preferences, aspirations, allow this type of experimentation to assist in the process of conflict resolution. So with this in mind, thank you very much for your time, and happy World Water Day.
Thank you very much, Florian. That was great. I'll ask our final speaker.